Hey guys, how's this for a pretty awesome challenge today? We have which term of the sequence 5, 11, and 17 is equal to 101. Now in the previous challenges, we've just been working out what the value of a specific term is. Now we've got to find a position of a specific value, which is kind of cool, right? We're throwing our challenges from previous on their head, okay? So we're really just going to use our maths muscle and play with these challenges, okay? So as we can see, we have that sequence 5, 11, and 17. You know what I'm going to say? Let's write it out first. 5, 11, and 17. Okay. Now, doing our simple test to see if it's arithmetic or geometric, we ask ourselves, what do I do from 5 to 11? Well, I will add 6. And what do I do from 11 to 7? Again, I shall add 6. Pretty cool. So because we know that we have a constant first difference, we know that this is an arithmetic sequence. Okay, and we've been playing with our standard form for so long, we should know it off by heart by now, which is Tn is equal to a plus, open bracket, n minus 1, close bracket, d. Okay, now let's check. What does the a mean? What does the d mean? Okay, a is always the value of the first term, which in this case is 5, and d is the value of the difference. Okay, what is our difference? It is 6. We're adding 6 each time. Okay, so let's go ahead, use this bit of information and create a general nth term. And let's do it. Tn is equal to a, and we said a has a value of 5. Alright, plus open bracket, n minus 1, close bracket, and now we have d, which has a value of 6. Okay, let's clean this up, get rid of our brackets, and see what our beautiful general nth term will look like. Okay, nothing is officially affecting the 5, so it will come down as is. Fantastic. Then we have the 6 multiplied by an n, which is going to give us 6n. Alright, and then we have 6 multiplied by negative 1, which is going to give us negative 6. Okay, so cleaning up a little bit more, we're going to bring our variable in first. So we have 6n. Looking at our constants, we have 5 minus 6, which is going to give us minus 1. Okay, this is what we have calculated to be a general nth term. Always test it. I'm going to go for the dude in the middle, which is T2. Alright, we have T1 on our left and we have T3 on our right. Okay, so when we are testing this, basically wherever you see an n, we're going to put down the number or the position of the term that we're working with. And I'm working with term 2. So T2, right, is equal to 6. Ooh, I've just bumped into an n, so that means we need to plug in a 2. Okay, and minus 1. Awesome. Okay, so let's think about this. 6 times 2, well, that's easy. It's 12. And 12 minus 1, let's check. It is 11. Is that the value of our second term? Woohoo! It is. Okay, that means our general term is correct. Fantastic. Okay, so we've been doing this a couple of times already, and nothing has changed with this sequence, right? We've just gone ahead and calculated what our general nth term is, and we have tested that it works. Now, in the past, we would have basically said what term we're looking for, but this time we've got a value. Okay, so we've got to create we're going to make our formula using our general nth term to find out where the position of 101 is going to be. So remember, our general nth term is 6n minus 1. Now, on the left-hand side, we would usually say t and then the specific number, usually like 25 or whatever the case is of whichever term they're asking for. But because this is a value, we're literally just going to put the number. Alright? Because by the time we get to the last number, that is the term that this will be. Okay, so let's have a look. See, let's play with this. It's good old-fashioned algebra. Okay, always want to move the constants over. So when a negative 1 jumps over that equal sign, it turns into a positive. So we have 101 plus 1 is equal to 6n, right? Which is 102 is equal to 6n. We want to separate, we want to get n just by itself, so we're going to divide it by 6. Okay, always dividing by the number in front of the variable. So the 6's cancel out, giving us n, and 6 goes into 102 times 17. into 102 17 times. Okay, therefore, term 17 is equal to 101. Well done, hey? Not so difficult. Let's go ahead and try another challenge. Chat to you just now. Cheers.